Today you're going to talk about the negative rule of negative exponents. So we're going to start out, just like we have before, on our negative exponent sheet, taking our notes. So if you'll flip to the corresponding page in your packet, this is page 13, and we will start here with our notes. So you'll see the first one's been done for you. You have 2 to the second power divided by 2 to the fifth power. And we know our rule for quotients is that we keep the base, 2, and we subtract from top to bottom. So we would be saying 2 and then 2 minus 5. So that's going to end up with a negative exponent. So if you notice down here at the very end, we have a negative exponent. So let's see how we got that. There's a special rule with negatives that we have to follow. So this basic part you should be able to do with the quotient rule. So we had 2 times 2 at the top because we had 2 exponent, and then we had 5 at the bottom. They crossed out and we're left with 2, but they're on the bottom. So we have 1 over 2 to the third power. This is actually how we should leave the answer. If we had to put it in exponent form, we would actually put it as a negative. Usually we don't start right into this category. We end up with the 2 to the negative 3, and then we have to change it to a fraction. So let's talk about it a little bit different. If we do it as a repeated addition, we have a times a times a times a. We had 4 on the top, and then we have 9 on the bottom. So take a few seconds to write those out. 4, 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And then we would cross out the ones that cross out. We would have just 1 left on top because a times a times a times a is just 1. There's always a 1 in front of coefficient whether we see it or not. So we have a 1, and then we have 1, 2, 3, 4, 5 on the bottom. That's what our true answer should be. Now if we use our quotient rule, we would have a's, we keep the a, and then we subtract 4 minus 9, 4 minus 9, and we would get a to the negative fifth. We never want to leave exponents as negative. They're not happy. So we've got to think about that when we do it. So this one, writing it in the form of a negative, is not the final step. The final answer would be in this column right here. And we need to always remember we have to make them happy. So here, when we have a over 4 to the 8th, we have to think, how do we get there? So obviously we started with our base of 4 as something, 4 to something, and 4 to something else. But our smaller number would have been on top. So we think about, what will we have left? Well, we had to have 8 little 4s left on the bottom. So 8 of those on the bottom. And then we would have had something that marked out some other ones to give us 4 left. So maybe we had to the 12th, and we had maybe 4. 4 minus 12 would give us 8. And it would be a negative 8, but that stays on the bottom, so we flip it to a fraction. So we're going to move down to this section right here and talk about them the correct way we want to do them to make them happy. And I use that term a lot because it's very easy to remember. Are they happy or not? So again, we simplify and look at our a's separate from our b's. So we have a, 4 minus 9 will give us a to the negative fifth. Then we look at our b's. B stays, and then 5 minus 12 will give us negative 7. So if we write it in this form, a to the negative fifth and b to the negative 7th, these are not happy. Nobody's happy when they're negative. When they have a negative attitude, you're not very happy. So think about this as the top of a house. This is a numerator over a denominator. We can put any number over 1. It doesn't change the value of the number. So we ask ourselves, is A happy? Well, no, he's not happy. He has a negative exponent. So if we move him to the bottom of the house, he'll be happy. So we're going to write this as a fraction. He was at the top and not happy, so we're going to move him to the bottom. When we move him to the bottom, automatically he becomes happy. His negative disappears, but his 5 stays. The same with B. B's at the top of the house right now. He's not happy, so we're going to move him to the bottom of the house, and his exponent becomes positive. We can't just have a fraction without a number in the numerator, so we put it as a 1. Okay, so now let's try the next one. Notice we have 5 to the 0 power. 5 to the 0 power, or any number raised to the 0 power, as you recall, is 1. And then 25 to the 4th, that is saying 25 times 25 times 25 times 25. So we'll rewrite it as repeated multiplication. This is the same thing as saying 1 over 25 to the 4th. And this would be our correct answer. Now, if we didn't realize that and we wanted to take and find out what these pieces are, these are not like bases. So we cannot use the quotient rule of subtracting our exponents. So this is the only way we could do it. Okay? All right. So let's talk about, what does a negative exponent mean? And we're going to look at the two columns on the right and try to formulate a rule. So if we have a negative exponent, what we're actually doing is we have to make it a fraction. It's actually the opposite or the reciprocal of what we have with a negative. So we have to make it a fraction. So when we look at what we're doing, we have to think about moving it from being a negative down to the denominator to be a fraction. All right, let's continue and look at our rule. Are positive expressions with negative exponents negative? So for example, if I said 5 to the negative 2, I would be saying the answer is negative, and that's not true. We're not raising 5, we're not multiplying 5 times negative 2. We're raising it as 5 to this negative power is the same as putting it at the bottom of a fraction. So we have to make it happy. So it goes into the denominator. Well, 5 times 5, or 5 to the second power, is the same thing as 1 over 25. So no, it is not negative. Okay? What do you think this simplifies to be? So this is 1 over 2 to the negative 3. So on this one, we start out as he is in the bottom. He is in the bottom and he's got a negative. He's not happy in the bottom of the house. He needs to go to the top floor of the house. So this is the reciprocal. So we would say 2/3 over 1. So we have to make sure he's happy. 1 can go anywhere. They're happy no matter what. He's good no matter where you put him. So this is the same thing as saying 2 times 2 times 2 over 1. And 2 times 2 is 4. 4 times 2 is 8 over 1. We don't need to write it over 1. We would just write it as an 8. So if it starts out on the bottom as a negative exponent, it must move to the top. The exponent doesn't change. We just want to make sure they're happy. So our rule that we're going to write, and we're going to add this to our yellow sheet shortly with our words, is if we have x and a, and we have x and b, we know that we keep the base and a minus b. So we'll continue a little bit with how that rule looks in just a minute, as far as we know that we would end up getting an x to a negative number. So maybe x to the negative b. And we'll talk about what we do with that in just a minute on the yellow sheet. So let's look at our next page, page 14, and let's do a couple of these together. So these do blend in some of the zero rules. So remember, we know when 7 raised to 0 power, we know that is 1. So if we look at 1b, so we got an A column and a B column. If we look at 1b, we have 4 to the negative 3. You can think about this as 4 over 1. So we are having written as a fraction. Well, he's not happy on the top. He's not happy on the top of the house, so we have to move him to the bottom. They just basically switch spots. So then we say 4 times 4 times 4, and we could simplify that out. So you can use your calculator to do 4, do the little caret and the 3. So 4 times 4 is 16, and then 16 times 4, if you were doing it longhand, 24, carry 2, 4, 64. So we would know this is the same as 64 under 1, so 1/64. Okay? All right, so if we look at 2a, we have 7 to the negative second power. This is the same as 1 over 7 to the positive 2 power. Now we know that is 1 over 7 times 7 is 49. Okay? Now, be careful when you have 0 raised to the 52 power. Don't think that's automatically going to be 1. It's not raised to the 0 power, so be careful with that. All right, then you have some mixed in here that are ones we've been doing, and then we have some with negatives. So continue on this sheet. This is what you need to finish for practice. All right, let's go to our yellow sheet, and let's add our exponent rule for our negative. It's the very bottom rule. So we're going to write it the way we know. If we get an exponent, say our base, whatever our base may be, number or variable, and we have a negative exponent, we'll call it a negative a, we know that we have to do the reciprocal or make it a fraction, 1 over x to a positive a. So when we have negative exponents, we have to make sure they're happy, and that's a really important little word we're going to put here. So we want to move the exponent up or down, depending on where it started, to make it happy. Okay, very important. All right, if you'll continue with your practice and check Canvas for your other assignments.